In 4.5, we are going to start graphing sine and cosine functions, but first I want you to see the parent function before we graph it on our own. This is y equals sine x. It's periodic. You can see it's repeating. It makes a nice curve. It's sometimes kind of called a sinusoidal curve. And if I look at this point to this point, that completes one period of the graph. After that, it repeats, repeats, repeats. Okay, let's look at cosine real quick. Okay, cosine looks very similar to sine, has a different y-intercept, but it still has a period of 2 pi. So if I start here on the cycle of the graph and then I continue it to here, if I just repeated this portion of the graph over and over and over again, it would continue the sine graph infinitely. Okay, now that we saw what sine and cosine will look like when we graph them, we're going to go over how we could graph them on their own. And using the different kind of period changes, amplitude changes, and things like that. Okay, now I'm going to sketch the unit circle. Okay, now the 4 easiest corners of the unit circle to remember are at 0, at pi over 2, at pi, and at 3 pi over 2. And luckily, we can do most of the graphs using just those 4 corners of the graph. Okay, first we're going to look at sine. Okay, let's see. Because I want to space it out so I hit those 4 corners of the graph, I'm going to go ahead and space it like this. This is pi over 2. This is pi. 3 pi over 2. This is 2 pi. It does not have to be spaced like this, but I do want to make sure I hit the 4 corners of the cycle. Okay, let me think. Okay, let's go ahead and start this off at 0. The sine of 0 is the y value. So the sine of 0 is 0. So this graph starts at 0, 0. Okay, if I go up here, at pi over 2, the sine value is 1. So at pi over 2, let's go up to 1. At pi, the sine value is 0 again. At 3 pi over 2, the sine value is negative 1. And if I continued back to here, this is now 2 pi because I've completed a loop, and it goes back to 0. Okay, I'm going to trace just this portion of the graph. It should curve. This is a curve. Okay, this is about one period of the graph. I could extend this graph further, and I would because it does, following the same pattern. It goes up 1, back to 0, and then it would go that way. In the negative direction, it does the same pattern. Okay, and I can see the nice curve of this graph. Okay, I'm going to go ahead and graph cosine as well. Okay, for cosine, remember the cosine is the x-coordinate if I'm using the unit circle. Okay, I'm going to space it the same way, I think, because I want to hit pi over 2, I want to hit pi, I want to hit 3 pi over 2, and I want to hit 2 pi. Okay, my spacing could be different, but I do want to hit those 4 key points because it makes my life easier. Okay, if I start at 0, the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And if I went all the way back to 2 pi, I go back to the 1. Okay, this is one period of cosine. And it should curve because this is a curve just like we saw in Desmos. Okay, and this does extend further. If I continue, this was up to 1, now it's at 0. Down to 1, and it would continue back up to 0. And in the negative direction, same. This is at 1, back to 0, down to negative 1, and it would continue to curve from there. Okay, so for both of these functions, the domain is negative infinity to infinity because it extends forever to the left and the right. For the range, they have a minimum y value of negative 1. They have a maximum y value of positive 1, and it does equal to those values because the sine of 0, the cosine of 0 is 1. So it has to equal to it. Okay, the period is how long it takes to do exactly one cycle. That was one loop around the unit circle. So the period is going to be 2 pi for each of these, and then the graph just repeats after that. The amplitude is how far up and down it goes from the midline. In this case, the x-axis is the midline. The graph goes up 1, goes down 1, up 1, down 1. So the amplitude is 1. Same for cosine, and the amplitude is always a positive value because it's a distance from the midline. Okay, for the sine graph, let's look at some of our x-intercepts. There are infinite x-intercepts, so I'll just list a couple. Okay, I see one at 0, 0. I see one at pi 0. And there's infinitely other ones. Let's see, a minimum and a maximum. There's a minimum right here. That is 3 pi over 2, 0. No, 3 pi over 2, negative 1. That's the lowest point on the graph. There's also one here. This is negative pi over 2. There's a maximum up here. That's at pi over 2. Okay, and there's infinite other minimums and maximums on the graph. Okay, the x-intercepts on the cosine, I see one here. And that's between 0 and pi, so that's at pi over 2, which makes sense because the cosine of pi over 2 is 0. There's also one at 3 pi over 2, 5 pi over 2, and so on. Okay, there's a minimum right here at pi, negative 1, because the cosine of pi is negative 1, and there's a maximum at 0, because the cosine of 0 is positive 1. These are the two parent functions we're going to work with. Okay, so in the box you see that the general formulas or the general equations for sine and cosine functions. Okay, y equals a times sine bx minus c, y equals a cosine parentheses bx minus c. Okay, this number in front is going to indicate the amplitude, the absolute value, when you absolute value it, because amplitude is always positive. The period of the graph is not always 2 pi. If there's a number in front of the x, then your period will be 2 pi divided by b. Okay, and then sometimes it is useful to find the endpoints of a cycle, and that can be found by setting these parentheses equal to 0 and to 2 pi. Okay, this is kind of indicating kind of a period shift, and it also shows about like a horizontal translation. Okay, let's try these first couple basic ones out. Okay, let's see. This is sine of x, so the period stays 2 pi. The amplitude is going to be 3 because the absolute value of 3 is 3, and this is a sine function. Since the period's 2 pi, I know I want to make it to 2 pi. And normally if we divide it into 4 spaces, 4 equal segments, that helps get our 4 key points here. Okay, now let me think. Think of the 4 corners of the unit circle. Okay, the sine of 0 is 0. The sine of pi over 2 is 1, but it's actually going to be 3 times 1 because the amplitude's 3. So 1, 2, 3. I'm going to go all the way up to the 3. Okay, when I get to pi, the sine of pi is 0. When I get to 3 pi over 2, the sine of 3 pi over 2 is negative 1. But because the amplitude is 3, I'm timesing it by 3. 1, 2. So I go down to here. And I go back to 0. Okay, once you see that one period of the curve, I'm going to draw it in a different color. This is one period. It's just going to repeat after that so I can follow the same pattern. So this hits 0, should go up to 3, back to 0, and then if I kept going, it would go back down. Okay, it does continue forever. Okay, and same if I went back here, down to 3, it should go back up towards the 0. Okay, let's look at the next one. It says y equals negative sine x. Because the x doesn't have any coefficient, the period is still 2 pi. The amplitude is the absolute value of the coefficient. So let's see, since it's negative 1 sine x, the amplitude is still 1. But because of the negative, it's going to kind of reflect off our normal sine parent function. The period's 2 pi, so I'm going to space it out so I can hit those 4 corners between 0 and 2 pi. Okay, I'm going to go back and I'm going to think about those 4 corners of the unit circle. Okay, the sine of 0 is 0. The sine of pi over 2 is 1, but because I'm reflecting it or I'm multiplying by a negative, instead of going up 1, it goes down 1 for my first move. And then I go back to 0. Okay, you should be starting to see a pattern now. I was at 0, I went down 1, I'm at 0, which means I must be going up 1. Then I'm going to go back to 0. You're going to start to see the pattern more. Once you see the pattern, you're just going to go with the pattern. Okay, that's one period of it, but this graph extends from negative infinity to infinity. But once I see the pattern, I just continue the pattern. So this was 0, up 1, and then it would go back down to 0. Okay, let's try to do some stuff with cosine. Okay, this is a cosine function. The period is still 2 pi because the x is not being affected. The amplitude is the absolute value of 4, so it goes to 4. Since the period's 2 pi, I'm going to make sure I hit 2 pi, and it's nice if we can split it into 4 equals, space it out into 4 equal points so I can hit the 4 corners of the unit circle. Okay, now let me think. The cosine of 0 is 1, but the amplitude is 4. 1, 2, 3. Oh, so I go up way up here. I'm a little too big for the graph. That's okay. Okay, pi over 2, the cosine is 0. At pi, the cosine is -1, but the amplitude's 4. So instead of -1, -1, -2, -3, -4. 3 pi over 2, I'm back to 0. 2 pi, I'm back up to 4. Okay, this is one period of the graph. But I know it's going to continue in that pattern. So up 4, 0, down 4, and it would go back to 0. Same on the other direction, 0, down to 4. Let me sketch this graph. Okay, that's my cosine curve. Okay, let's do the next one. It's going to have the same period. D is y equals 2 plus sine x. Okay, so let's see. The period is still 2 pi. The amplitude's actually 1 because the coefficient is technically 1, but it has that weird +2 in the front. The +2 is moving the graph up 2. Okay, some people like to draw a midline at up 2. I'll draw it in so you can see what it looks like. Okay, if this is moving up 2, it moves the midline up 2, which I'm going to make a dashed line because it's not a real line on the graph. You don't need to draw the midline, but it can help you make sure your graph is centered. Okay, so I went up 2, but I'm still graphing this sine function, so I'm going to think about the 4 corners of this sine function. So the sine of 0 is 0, but I'm up 2. And then the sine of pi over 2 is 1, but I'm up 2. The sine of pi is 0, but I'm up 2. Okay, and then at 2 pi, I get back to my midline. You can see that this graph is centered on the midline, which is why having the midline there does sometimes visually help you recognize if your graph's going the right way, and it does continue because this is periodic and it extends infinitely in both x directions. Let's see what that does. Okay, let's see, the period on this one, because it's just an x, is 2 pi. The amplitude is 2. Okay, and the -3 in the front represents a vertical shift down 3. So I'm going to redraw the midline down 3. 1, 2, 3. Okay, remember midline's not necessary, but it does help center your graph. Since the period is 2 pi, I'm going to space it out in some way so that the 2 pi is split into 4 clear points so that I can go around the unit circle easily. Okay, and then the amplitude of cosine is 2. Okay, so I'm going to graph it from the midline, pretending like the midline is my 0. Okay, the cosine of 0 is 1, but it has an amplitude of 2. So from the midline, I'm going to 2. Pi over 2, the cosine is 0, so I'm going to stay at my midline. The cosine of pi is -1, but the amplitude's 2, so I'm making -2. Then I go back to my midline. Then I go back, I finish my period at 2 pi, and then it would continue this pattern infinitely. So let me extend it a little bit in each direction so it doesn't look like it's ending when it's not. Okay, now for f, we're going to start changing the period to see what that looks like on the graph. Okay, let's see, the period in this case is going to be 2 pi over 5, which is just 2 pi over 5. Okay, the amplitude is 2, which is okay. Okay, now, even though the period's 2 pi over 5, it actually does not change much about how I graph it. The only thing different is, let me think, I'm going to space it out. Instead of writing 2 pi here, I'm going to write 2 pi over 5 here. This way my graph will look very similar to what I'm used to. Okay, I still split it into four pieces so I can get to 0, pi over 2, pi, 3 pi over 2, and blah, blah, blah. If this is 2 pi over 5, then if I go halfway this way, this is actually 1 pi over 5. Okay, yeah, but the way I graph it is going to be to just graph the sine function. The sine of 0 is 0. Normally at pi over 2, the graph goes to here. This is actually pi over 10. Pi over 10 times 5 gives me pi over 2. But as long as I follow the pattern, back to 0, down to 2, and then when I end the period, I should end at 2 pi over 5. So this looks exactly like a normal 2 sine x graph, except instead of ending the period at 2 pi, I ended at 2 pi over 5, and nothing else in the graph changes except for basically the labeling of my x-axis. Okay, we're going to change the period on the next one, and again, when I change the period, how that actually affects the graphing process just means I'm probably going to change the labeling of my x-axis. Okay, let's see. It says pi x, so the period is 2 pi over pi, which equals to 2. The amplitude is 1, and then this 3 in the front means that I'm going to go up 3. I'm going to resketch the midline up 3. Because I do like to recenter my graph. The period's 2, so I'm going to space it out as I normally would, but instead of ending at 2 pi, I'm going to put a 2 here. If that's 2, I put a 1 here. Okay, the shape of my graph will not change as long as I've adjusted my x-axis accordingly. Okay, the sine of 0 is 0, but I'm moving up 3, so I'm going to stay on my midline. At pi over 2, I go up 1 from the midline, back to 0, down 1, back to 2. Okay, this looks just like as if this were 3 plus sine x, but the period changed. My x-axis changed. You might be thinking, how can that possibly be the same? But if I plug this 2 into this equation, pi times 2 is 2 pi. So this makes sense that this is the 2 pi point. If I plug this in, pi times 1 is pi. The sine of pi would match up to that point. So it does always work out, even though you feel like you're ignoring parts of the math. Okay, for h, it's a cosine function. It has a negative in the front, and we're going to mess with the period. Okay, so in this case, the period is 2 pi over 2, which is pi. The amplitude is positive 2. The amplitude is always positive. The negative is going to indicate a reflection. Okay, and when I space my x-axis, I'm going to pretend like I'm doing it like normal, but instead of writing 2 pi, I'm going to write pi. And that will reflect the change in the period. If that's pi, then this must be pi over 2. But I'm going to graph it like I normally graph it and then make it work. Okay, the cosine of 0 is 1, but the amplitude's 2 and it's negative, so I'm going to start at negative 2. I go back to 0, hit the positive 2, 0, down to negative 2, and then it will continue from there in the same pattern. And once I see the pattern, I can just sketch the graph. I'm going to curve it. Okay, but even though this looks like a normal cosine function, the period did change because if I start the cosine cycle here, it completes one cycle right here, and this is at pi. So this is one period completed in pi. Okay, the last thing we're going to do with the sine and cosine functions is horizontal translations, and I will show you a couple ways to do it, and depending on the function or your preferences, you might choose to do it one way versus the other. Okay, in parentheses, I have x plus pi over 6, which means this function is moving left pi over 6 from the parent function. The period is 2 pi, and the amplitude is 2. But because I'm moving left pi over 6, I would probably space my scale out so that pi over 6, it's easy for me to read. Meaning, I'm going to make 1, 2, 3, 4, 5, 6 spaces for pi. 1, 2, 3, 4, 6 spaces for 2 pi. And the reason I'm doing that is because if there's 6 spaces for pi, then each of those spaces must be pi over 6, and that will make it easier for me to move left pi over 6. Okay, I'm going to do it by translating it, and then I'll show you using the formula that I gave you at the beginning. Okay, normally the sine of 0 is 0, but I'm moving it left pi over 6. So now it's over to here. Okay, at pi over 2, I'm going to mark pi over 2 so it's easier for me to see. At pi over 2, it normally goes up to 2 because of the amplitude, but because it's moving left pi over 6, I'm going to move it left pi over 6. At pi, it goes back to 0, but I'm going to move left pi over 6. 3 pi over 2, we go down to 2, but I move it left pi over 6. And then 2 pi, we get back to 0, but I'm moving it left pi over 6. Okay, so we can see that this is the sine graph with an amplitude of 2, but it is shifted left pi over 6 based on my scale. Okay, the formulas at the beginning of the book or at the beginning of this section said if you want to figure out how to shift the cycle, I could do x plus pi over 6 equals 0. X equals negative pi over 6 is going to tell me the start of a cycle, which is this point. If I set x plus pi over 6 to 2 pi, which is 12 pi over 6, and I subtract pi over 6, I get 11 pi over 6, and that's going to tell me the end of the cycle, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 is right here. Okay, and if you knew the beginning and the end of the cycle, you could divide that into 4 equal spaces to find these 4 points that we graphed by shifting left pi over 6. Your graph would look the same, your result would be the same. Okay, for B, this is a horizontal shift. Because the period is not affected, I find it easier to just do a shift or a translation with it. This is going right pi over 4. This is a cosine function with a period of 2 pi and an amplitude of 3. Okay, because I want to move right pi over 4, when I scale to pi, I'm going to consider how to space it based on the fact that I want to move pi over 4, and it's easier for me to count fourths with certain numbers. So I'm going to go 1, 2, 3. I'm going to make this pi. That means each of these spaces is pi over 4. 1, 2, 3, 4. That makes this 2 pi. And what's that? That would be pi over 2, 3 pi over 2, etc. Okay, according to my scale, because pi over 4 is divided into 4 units, each one of these spaces is pi over 4. So I'm going to shift right pi over 4. If I was shifting 3 pi over 4, I would move 3 of these spaces. Okay, let me consider a cosine function. Okay, the cosine of 0 is at a maximum. It's at 1, but the amplitude's 3. So normally I have 3, but I'm moving right pi over 4. Okay, when I get pi over 2, I go back to 0, but I'm moving right pi over 4. Pi, I go down to negative, but I move right pi over 4. 0, but move right. Back up to 3, but move right. Once you see the pattern, you could start plotting the other points to fill this in. Okay, and then I'm going to sketch my function. And I can see it's a cosine function moved right pi over 4. If you would like to use the formulas, I'll show you how those match up. X minus pi over 4 equals 0 means that my cycle starts at pi over 4, which makes sense because the cosine maximum's there. X minus pi over 4 equals 2 pi, which is 8 pi over 4. So it should end at 9 pi over 4. So 4 pi over 4, 8 pi over 4, this is 9 pi over 4. So that matches up with what I expected. Okay, for C and D, there's going to be a period shift. When there's a period shift, sometimes it is useful, really useful, to consider the starting and ending points of my graph. Okay, so this is a cosine function. The period is going to be 2 pi over 2, so the period's pi. The amplitude's 2. Okay, but because I have a period shift and a horizontal shift, it's going to affect my horizontal shift. So this is not moving left pi over 2. This is moving left pi over 2, but also having a period shrink in half. So then the horizontal shift, the horizontal translation shrinks in half as well. So I'm going to just set this equal to 0 to figure out where it's going to start or what my shift actually is. Okay, divide by 2 or take half. Okay, so one cycle is going to start at negative pi over 4, which means I'm shifting left pi over 4. But because my period's only pi, if I added pi to this, I could tell this is going to end at 3 pi over 4. But I'm going to do it the way your book does it. No, 2 pi, what is that? 4 pi over 2 minus pi over 2 is 3 pi over 2. And then if I take half of that, I get 3 pi over 4. So I should complete one cycle from negative pi over 4 to 3 pi over 4. Okay, so I want to think about how I want to space this out. Okay, I want to make sure I have at least 4 dots. I think I'm going to make this negative pi over 4, which makes this positive. Oh, I wrote that wrong. Make that a 4. Okay, so this is positive pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. Okay, and the reason I spaced it like that is I know it's going to start here, it's going to end here, and it's cosine, so it's going to look something like that. And between there, I can hit the 4 corners of the unit circle, and I can graph according to that. Okay, so I'm going to start my cosine cycle at negative pi over 4. At negative pi over 4, the cosine cycle starts, and it starts at its maximum. At 3 pi over 4, it ends at its maximum. So in between, I need to figure out what's going to happen. Okay, halfway in between, it's going to get the minimum, and it's going to go 0, 0. Okay, and think about the unit circle. It starts at, normally the unit circle goes 1, 0, -1, 0, and then back up to 1. That's the pattern. And because this is periodic, I can pick up the pattern anywhere and then use that to graph it. Okay, and then let me glance back at this. It shifted left pi over 4, which is why the cosine started here. The period should only be pi. So from negative pi over 4 to 3 pi over 4, that is 4 pi over 4, which is pi, and it completes one full cycle from negative pi over 4 to 3 pi over 4. Okay, one last graph, putting everything together. Okay, let's see. There's a period shift on this. So if I do 2 pi divided by pi over 2, that's 2 pi times 2 over pi. So the period's actually going to be 4. The amplitude is 1, but this graph is also has a vertical shift. It's going to go up 1. So I'm going to go ahead and redraw the midline up 1. Okay, don't have to draw the midline, but it does help you look at your graph and tell if it looks like it's doing what it's supposed to do. Okay, because there's a period shift and there's a horizontal shift, I'm going to set it equal to 0 to see what the real shift is. And to see where to start my cycle. Let's see, pi x over 2 equals pi over 2. So x equals 1, so my cycle is going to start at 1. Okay, now I want to figure out where it's going to end. Now there's a couple ways to do it. One is to see that the period's 4. So if I start at 1 and I have a period of 4, I'm going to end at 5. Okay, I like to do it that way. Your book sets it equal to pi over 2, which also always works. Or, sorry, not pi over 2, 2 pi. Let's see, pi x over 2 equals 4 pi over 2 plus pi over 2 is 5 pi over 2. 2 cancels, pi cancels, x equals 5. Okay, so we agree on where it's going to start and end. I want to think about how to space this out. Okay, from 1 to 5 is 4, which is nice because 4 divides the unit circle into the 4 nice corners. Okay, I'm going to space it like this. I'll make this 1, 2, 3, 4. This will be 5. That's going to be the end of one cycle. Okay, what is this? This is a sine function. So let me think about a sine function. Okay, and it starts at 1. So the sine cycle starts at 0. Okay, it also ends at 0. And in the middle, it hits 0. Okay, between here and there, it goes up and it goes back down. Does this look like sine? 0, 1, 0, -1, and back to 0. I started one cycle at 1. I ended my cycle at 5. It has a period of 4, and it was shifted up 1. Okay, now we don't leave these floating in space. I almost always ask you to extend this through at least your y-axis so we can see how that's hitting, and also because I can check your y-axis. Okay, that's kind of combining everything we can do so far with sine and cosine.